Bismillah ar-Rahman ar-Rahim, the Vice Chancellor of Postgraduate Studies and the Research Scientific Professor Abdalazziz, the delegations of the University of California, Arfain, our colleagues, the lecturer and the deans at Salman bin Abdulaziz University. The University of Salman pleasantly welcomes the honorable delegation of the firmly established University of California, Arfain, for the sake of constant communications, setting new horizons in the field of the scientific research, and systemizing the constructive efforts to develop education at all levels for the good of the society. Now, we are going to listen to a recitation of some verses from the Holy Quran, read by the students Muhammad al-Khami.
أعوذ بالله من الشيطان الرجيم. يا أيها الذين آمنوا اجتنبوا كثيرا من الظن إن بعض الظن إثم ولا تجسسوا ولا يغتب بعضكم بعضا أيحب أحدكم أن يأكل لحم أخيه ميتا فكرهتموه واتقوا الله إن الله تواب رحيم. يا أيها الناس إنا خلقناكم من ذكر وأنثى وجعلناكم شعوبا وقبائل لتعارفوا إن أكرمكم عند الله أتقاكم إن الله عليم خبير.
Here comes now to the Vice Chancellor of Postgraduate Studies and Scientific Research, the man whose favor is not to be forgotten in enhancing our relationships with the international universities, and the pioneer in coming up with the new strategies in regard to a cultural exchange, the humble Professor Abdalazziz. Let's listen to his speech.
Assalamu alaikum wa rahmatullahi wa barakatuh. First of all, I would like to excuse our guests. I have to speak in Arabic, and then I will speak in English as we did in your school back home. Bismillah, wassalatu wassalam ala rasulillah wa ala alihi wa sahbihi wa man walah, amma ba'd. سعادة الأخوة الوكلاء، سعادة الأخوة عمداء الكليات، وكلاء الكليات، سعادة أعضاء هيئة التدريس والموظفين أبناء الطلاب، السلام عليكم ورحمة الله وبركاته. الحقيقة هذا يوم يعد من الأيام التاريخية لجامعة سلمان بن عبدالعزيز، حيث يوجد بيننا كوكبة من علماء جامعة من الجامعات التي تعد، وبإمكانكم سؤال الأعضاء أنفسهم عن هذا ما يسمى بالرانك، تعتبر الجامعة الأولى على مستوى جامعات أمريكا، والجامعة الرابعة على مستوى العالم فيما يسمى بكل الجامعات التي أنشئت خلال 50 إلى 54 عام. فهي جامعة ناشئة مثلنا ولكنها عمرها 54 سنة، وجامعة ما شاء الله يعني لديهم من الريسورسز اللي هو يعني مصادر مالية كبيرة وهائلة جدا. هم راح يشرحوا لكم عن جامعتهم، لكن حقيقة نحن كجامعة سلمان جامعة ناشئة، ونبدأ بهذه إن شاء الله القوة، وأنا أعتبرها حقيقة قوة، لأن لم نجد يعني جامعات ناشئة وصلت إلى ما وصلنا إليه. والحقيقة في أمر أريد أن أقول للإخوان خصوصا العمداء الموجودين، وأنا حقيقة تفاجأت أن لا يوجد عمداء من الجامعة، لكن على أي حال إن شاء الله يأتون فيما بعد. الأمر هو أن هناك اتفاقية بيننا وبين جامعة UCI كاليفورنيا مفتوحة، بين وقعتها مع مدير الجامعة لجميع الكليات، كليات طبية، كليات هندسة، كليات علمية، كليات أدبية. والجامعة عندها توجه قوي جدا، ليس على مستوى الشرق الأوسط فحسب أو السعودية فحسب، هي على مستوى العالم. والآن نجحوا نجاح قوي وبالغ في شرق آسيا مع كثير من الجامعات. فأقول الحمد لله لوجود هذه الكوكبة من إخواننا، وفي موجود طبعا بعضهم من أصل عربي وهم من ساعدونا كثيرا. فأنا حقيقة أطلب من إخواني عمداء الكليات الأخرى غير الهندسة وهندسة الحاسب أن يبدأوا مع إخواننا لكي نعمل ما يسمى اتفاقية مبدئية توقع إن شاء الله في القريب العاجل. ومدير جامعة هذه الجامعة رجل مشهور جدا، دعي بدعوة خاصة من وزارة التعليم العالي، وسوف يأتي إلى المؤتمر إن شاء الله المقبل. فهذه فرصة جيدة لمدير جامعتنا أن يوقع معه اتفاقية لكل كلية، والكليات التي لديها طبعا رغبة في ذلك. والجامعة مفتوحة وفتحت لنا ذراعها، وأأمل من إخواني أنهم يعني يبدأون في هذا المضمار. الأمر الآخر، إخواننا هنا نرحب فيهم طبعا، لكن I have to say it in English، ونشكرهم على القدوم. والآن يعني أتكلم معهم بالإنجليزي، سامحون لي. Dear brothers, first of all we welcome you and we know that you take a lot of what it means hassles to come to Saudi Arabia. Also this time you give it to us from your time, which it means you have Thanksgiving there and you spend some time with your family and you give it for us. So we are thankful for you guys to come here, and we are your friend and you have to take care of us. And this is Saudi Arabia. We are welcoming you, and this is a new environment, a new home for you guys. Maybe you can see it and maybe you will love it. Maybe you say someday we will sit with you here. You don't know. So we are welcoming you and thank you very much for what you are doing and what you have done and what you will do in the future. And all of my friends here is welcoming you or are welcoming you, and we hope we will have a long cooperation between UCI and Salman ibn Abdulaziz University. Thank you very much, and my friends here inshallah will cover up some detail which I didn't cover. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.
Okay, now let's watch the presentation on the University of California, Arfاين, by the Dean of Henry Samuel School of Engineering, Professor Gregory Washington, alongside with Dr. Ahmed Tawil and Professor Fadi Al-Gardahi.
First of all, I bring you greetings from the University of California, Irvine. I guess in the greeting words in Saudi Arabia, Assalamu alaikum. We're happy to be here. We may not be very coherent this morning. Many of us got in late last night. I think somewhere about 11 o'clock p.m. is the time that we arrived. And by the time we got through customs and hotel, I got to sleep closer to 2 o'clock in the morning. So we won't be totally 100% here, but we are so glad to be here with you today. And I'm very, very grateful for our partnership. I'm going to talk to you a little bit today about the Henry Samueli School of Engineering and talk to you a little bit about our partnership and the direction, some of the directions we see going forward. Just a little something about our program. We, in the United States, there's about 350 engineering programs throughout the country, and so we're ranked in the top 10% of those programs. We are have a fairly large number of students for a program of our size, somewhere in the neighborhood of about, in terms of engineering students, right around 3,600 total students. And we're what you call a research-intensive institution, meaning that the primary job of our faculty is to both educate students and to conduct cutting-edge research. So a couple of notable examples and outcomes of our school. We have very high quality students, one of the highest on our campus. You could see our entering freshmen come in now with about a 3.9 out of 4.0 GPA. The university overall is the highest ranked US university under 50 years old. And when you look at universities globally, universities under 50 years old, it's ranked number 4. We have 12 members in the National Academy of Engineering, and then we have a whole host of notable centers, and I won't talk about all of those in detail. I would like to highlight a couple of things. We currently are host to probably one of the country's largest programs in advanced vehicles, where we focus on electric vehicles, hybrid electric vehicles, combustion. Very strong program. And we also have our home to the lightest material to be developed in the world. A micro-lattice structure of nickel that's 1,000 times lighter than styrofoam. Our school is structured on 4 pillars, and I won't talk about all 4 of them here. I'll spend most of my time talking about partnerships because that's where we sit. But there are 4 pillars that structure the direction and aims and goals of our programs. You can see here, this is some data of what we're doing from the perspective of students. You can see both in the number of undergraduate students and in the number of grad students, the programs continue to grow, and they're growing at a tremendous pace. This year, we are well over 860 total graduate students in our program. Our research expenditures, as I said earlier, we are research intensive. Our research expenditures still continue to grow, and that's a very strong highlight of our program. We have 5 academic departments. 2 of them are represented here with me today. So later on today, you will hear from our department chair in mechanical and our department chair in electrical. So I won't go into detail in those 2 academic units too much. But here's, I will spend a little bit of time on the other 3. So our biomedical engineering department, you can see 21 faculty, you see the number of students and graduate students. These are some of the outcomes related to that department. Our chemical engineering and material science department is listed here as well. You can see some of the outcomes associated with those. Somewhere in the neighborhood of 260 undergraduates and about 86 graduate students are in that department. And then we have our civil and environmental engineering program, which has we had a fairly decent number of students come over from Saudi Arabia here last year. I think quite a few of them were involved and worked with our faculty members in civil engineering. I want to talk to you a little bit about partnerships. A few of the faces there should be a little familiar, but because of the program that we've had together and because of the outcomes of that, we have started what we're calling our Middle East academic program. And this is a collaborative program that seeks to strengthen new partnerships with Middle Eastern universities through focused student curriculum and also advanced research. And SAU is one of the cornerstone universities of that partnership. And so we really value the relationship. It's a big part of what we're doing going forward. If I were to highlight some of our long-term goals and where we're planning to go with this, we would like to continue to expand our program and to move it forward. We would also like to explore opportunities with other universities in Saudi Arabia as well. My personal goal is that we establish one new relationship over the next 3 years for a total of 4 different relationships over a 4-year period. We're also doing work with Tel Aviv University. This past year, we sponsored a conference with them, the communications technology, what communications and technology will look like in the year 2025. And so we have a number of active relationships growing in this region, and this is an area in which we look to expand. So that was my last slide. Thank you.
First of all, it's a pleasure to be here again. I was here about 2 years ago, and I can see a lot of progress on campus. I think the engineering building is completed now. When I was here, it was still basically on the ground. And also the dorms for the students is completed. So clearly there's a lot of work going on, and I commend you for how fast this is shaping up. So we look forward to the continued progress of SAU and the continued relation between UCI and SAU. So having said that, I have a tendency to speak fast. So I will try to pace myself a little bit and move in the presentation. Okay, so first I'll talk a little bit about the University of California, Irvine. So UC Irvine is part of a 10-campus system, which forms the University of California, which is one of the biggest educational institutions in the US. So we have, of course, our sister campuses. We have UCLA, where I graduated from, and also we have UCSD, which are closest neighbors, as well as Berkeley and many other campuses spread across the state of California. Now, specifically UCI is, basically this is an aerial shot of the campus, and I'm sure that some of the faces here who actually came to UCI this summer will remember the ring road, which takes you across the entire campus. And the way it's structured is that we have a park in the middle, and then we have all the schools around that park. And our engineering sector is that one indicated by the arrow, which basically houses our departments of civil engineering, electrical engineering, chemical and materials, as well as biomedical, and of course mechanical. So what do we want to do with international programs? Our mission is that we want to provide our students with an immersive educational and cultural experience via a comprehensive training program in both engineering and English. So we want you to be able to come to us, to be able to learn, of course, how to communicate your ideas in English, and also to be able to go to the labs and exercise these ideas under the mentorship of our faculty members and also our graduate students. So, and of course we want to make it fun, so you also get to visit a lot of the California attractions like Disneyland and so forth. But having said that, so we want you to have a fully immersive experience to see what the research is that we do at the university, how we run our education system, and also how we live our life. So what are the program components that we have? I'll talk a little bit about the different components of the program. Essentially, the first thing is the Summer Undergraduate Visitor Program, and this is what 15 students from Sلمان participated in this summer. And in that program, the students come over for the period of the summer, 10 weeks, and they study both English and engineering, as we said, under the mentorship of the faculty and also the graduate students. And at the end, they present their work, and that's the challenge. So in 10 weeks, the students are supposed to go into a symposium, have a poster, and defend their work to people that they've never seen before. So somebody would come, would ask you, what have you done? And you'd be able to explain in English what you have worked on in the past 10 weeks. And it was a great success, actually. We also have the English training part. In the English training part, we have a fully accredited English program. So the students come and spend half of the day learning English and half of the day in the labs. Something that we're going to implement starting this year is what we call the Academic Year Undergraduate Visitor Program. And in that specific component of the program, we choose the top students of the summer program, and we invite them to spend 1 whole year at UCI with a full fellowship. So they will be able to take classes with our regular students at UCI, take the same courses our UCI students take the courses, and in the end get a certificate that says these are the classes that they took at UCI, and they can apply this credit hours towards their graduation at Salman bin Abdulaziz University. Essentially, you're taking courses at UCI, and you're applying them towards your graduation here at Salman University. In terms of mentorship, we have a very well-structured mentorship program. So the students will be mentored by faculty members. So regular faculty members from our UCI departments will be working with the students on a one-on-one basis, both through the summer program as well as the academic year program. This will be complemented by having graduate student mentors. The graduate student mentors will be your point of reference. So essentially, you will be working with a graduate student, either a master's or a PhD student, and he will be guiding the students, the Salman students, through the life of a graduate student on campus. So they will see how the graduate students conduct their research, and they will work with them one-on-one in the labs to get their projects to work. This is an example of what we did this summer. So we had 15 students come over. The program ran from June 25th to September 4th, and we had orientation and welcome ceremonies on June 26th and June 29th. We expect that probably this year we'll follow the same schedule. So we'll start towards the 3rd week of June, receive the students, and have them spend 10 weeks at UCI. And then the final symposium where they presented their work was held on August 29th, and then they had the finals on August 31st. So this is a regular schedule. One of the complaints that I heard is that we made the students work a little bit too hard. So it starts at 8 o'clock in the morning, and you come and study English from, I see some smiles, so I hit a nerve here. But you work from 8 o'clock in the morning until around 2 p.m., taking your English courses, and then we have a break for half an hour, and then you come over to your lab, and you work in the lab from 2:30 until 5, except on Friday where we have a slot for the prayer, and of course the rest of the evening is off. And in Ramadan, we gave some leeway, but we maintained the same schedule. So they would come from 8 until 5. But I think it paid off, because in the symposium, everybody did a great job. So we were very work they put into it. So the program summary is that, again, we had 15 students from 5 different main programs here at SAU: computer science, computer engineering, electrical engineering, civil engineering, and mechanical engineering. And for 2013, we will continue along the same lines. We'll have 15 students coming in, and we will offer the top 5 to spend 3 academic quarters at UCI. These top 5 will be chosen based on their initial GPA, their performance in the English courses, as well as their performance in the project that they work on during summer. This is the program timeline that we anticipate for this run on summer. So the students will take an English placement test here in Riyadh during the month of December this month. And this would be basically just to place their achievement levels in English. It's not intended to do anything other than just saying this is their proficiency in English at this stage. Then after that, we will select, or the Salman with UCI will select the best 15 students. That will be in the January-February timeframe. We have a fully functional online portal, which we haven't posted online yet, but within a few weeks it will be available online. And this is where the students can go to submit their applications. Once that is expected to be done by early March, and then after that by April, we would have the housing, the airline tickets, and the visa process initiated. The visa will be issued by mid-May, and then we'll assign the housing by June and receive our students by mid-June. Okay, so logistics. Basically, the students will be offered a J1 visa. and for the duration of their stay. And in terms of spirituality, UCI is a very welcoming place. We receive people from many different parts of the world, and we strive hard to make sure that everybody is well integrated. So we have a building on campus called the Interfaith Center. This is where students can practice their religion. They can, it's available for Friday prayers. And again, it's a very tolerant, very cohesive community. Of course, healthcare will be provided to all the students, as well as access to bus passes that will allow them to go around Orange County, go to the beach, see all the nice stuff we have. Okay, one of the very important questions that we were asked many times, well, this is all great, but how do I eat? I want to make sure that when I go there, that I can have a good meal. So this is covered also within the program. We also cover the meals of the students. And for Ramadan, we had a very nice setup. So every week, we would have a group iftar between the students and the faculty. And that was a very interactive environment where we had a lot of fun. Also, the students will be given stipends, like a salary, that they can use to spend in Ramadan however they feel fit, because of course the nutritional needs in Ramadan are different than any other month. So they will be given a salary that they can use and have suhoor and iftar wherever they want. This shows all the spots on campus where you can eat. So believe me, when you come over there, you'll have a good meal. Okay, so in addition to that, we also had a cultural program for the students. So we took them to many places like Disneyland, California Adventure, Six Flags. Six Flags, I am happy or unhappy to say, is one place which I have never visited, even though I've been living in the US for a long time, because it's basically roller coasters. So if you like high flying, very adrenaline pumping things, go there, but it's not for me. And then of course we have Universal Studios, Huntington Beach, and Los Angeles and San Diego. So it's a very nice cultural trip. You get to see research, you get to see what we have in terms of attractions, and by the smiles on these people's face, I think they had a good time. Okay, so now let's talk a little bit about more serious stuff, program results. What did we achieve over the past summer? First, let's look at engineering. Now, in terms of engineering, this was a fully mentored program. In other words, there was both faculty mentors and graduate students working with your students to ensure that they succeed. So based on that, we ranked the students in performance according to satisfactory plus, satisfactory, and satisfactory minus. Essentially, all of them were able to finish their project, but they required various degrees of support. In other words, satisfactory plus means that the student was very independent and they were able to take on the initiative and do things on their own with some help from us. Satisfactory means that he met the expectations, we invested the right amount of energy, and they were able to finish their project. Satisfactory minus means that we had to invest a little bit more effort with the students to make sure that they finish their projects on time and they're able to present their projects well in the symposium. So this is the distribution of grades. So it was actually very nice results. We had 10 students who achieved satisfactory plus. In other words, they were able to complete their projects to the satisfaction of both the graduate mentors and the faculty and be able to present in the symposium. We had 2 students, and within satisfactory plus, of course, there's degrees. There's very satisfactory plus and medium satisfactory plus. And then we have satisfactory, which 2 students did that. And then we have 3 students who needed a little bit more extra help to finish their projects. In terms of English, we had 3 areas that we tested the students on. One is grammar, reading and writing, speaking and listening, and the 3rd area is reading and vocabulary. So the nice thing is that many students who could not communicate with the program staff at the beginning of the program, by the end of the program we were joking with each other. So that's a big progress. You're able to express yourself easily in English with your peers. So I think this is a metric, an unofficial metric, if I may say, that we use to make sure that the program is successful. And each student was responsible for delivering their symposium presentation on their own to people that they might have not met before. So this was another metric. Now, in terms of quantitative measurements, this graph shows you how many students were able to advance 1 level. By advance 1 level means that they were to pass the requirements for the 3 areas and are eligible to go on to the next level in English. So I'm happy to report that out of the 15 students, we had 12 students that had progressed on all levels. So all 3 areas that were measured, they were eligible to move on to the next level, and 3 that needed some extra help. Okay, so this is, I wanted to share with you some of the presentations and posters that the students had. So in terms of electrical engineering, which is my area, we had 2 projects, and this is one of them. And I apologize that I don't have time to show you all the slides. I'll just select random a few of the presentations. In this one here, they were doing a software-defined radio. And in this software-defined radio, the idea is that you're able to have an antenna, receive signals off the air using a hardware board, take these samples into the computer, write a software program that is able to demodulate an FM signal, and take that FM signal and send it to the speakers. So it involves hardware, because you're sampling signals in real time. It involves software, because you need to write a program that is able to demodulate your signal and display it or send it to the speakers. They were able to do that successfully, not only for one demodulator, but they actually tested 3 different types of demodulators. So they were able to implement FM reception in 3 different ways and compare and contrast the 3 different ways that these worked. I will go briefly over the other programs, and then Professor Fadi and other professors will talk about the respective departments. We had 2 projects in computer science and engineering. Both of them were involved in Android apps, and again, Professor Kardahi will talk in details about how this was implemented. But again, it involved both a software component and a hardware component, where they learned Java, for example, how to program in Java and C++, and they implemented programs on the actual hardware platforms, for example, like a tablet or an Android phone. In this case, it was a program that is used to identify prayer times and Qibla directions. For mechanical engineering, we had 2 projects. We had, specifically this project, for example, was for a multifunctional thermal protection system, which is essentially the plates that you put on spacecrafts when they enter into the atmosphere to protect them from the immense heat that is generated. And again, the student was able to go through the program and able to present it, and went into the lab and devised models, 3D printing models of different components. We had 4 projects in civil engineering. And in civil engineering, it focused on how to implement or how to mix cement to different levels. And again, I'm not a civil engineer, so don't put me on the spot with too many difficult questions. But in civil engineering, it was basically how to do cement mixes and come up with the specifications of these cement mixes. That was part of the project. The other part of the project had to do with specific graduate projects we had in the engineering school. So for example, in this specific case, the student was learning how to build the behavior of pultruded fiber reinforced polymer composites profiles. So these are the four samples of the different programs we had. Now I want to share with you some of the excitement of the symposium that we held. So I have a little video, and I hope the audio will be able to come out. We'll see. So bear with me a minute.
هذا الباكس like antenna, and يصار antenna for receiving the signal, and يصار to do some functions, down conversion and estimation. After that, we send the user PC to do some demodulations in a program that's called Kili Radio. This program. We do some functions with blocks, system blocks. We do some functions, athletics functions, to do demodulation. So you use the sound before
So I hope this took you over to Irvine with us to share the excitement we had with the symposium. And with that, again, it's a pleasure to be here, and we look forward to working with you in the future. Thank you.
Good morning, and I'd like to echo what my colleagues are saying. It's really a pleasure to be here. Last time I was here with Dr. Ahmed a couple of years ago, we had the opportunity of meeting the administration and the faculty. Since then, we have met the third component in the university, which is the students. You have sent us students over the summer. We had a chance to work with them. And basically, it was a pleasure to do that. As the deputy director for the program, my job is to interact with be the liaison with the School of Computer Engineering and Science, and also to work on accreditation and matters and articulation. So I'm going to talk about these two items in my presentation. So as far as the interaction with we had a number of students from the College of Computer Engineering and Science. And Dr. Ahmed talked about these projects. We had two projects that were involving a group of 2 students each. In the first project, we had, you saw in the demo, in the video that Dr. Ahmed has shown, it was an Android application that was patterned after a mobile application that we had for UC Irvine. And I asked the students to develop something similar for their college at SAU. Sure. اوكي سو التلاميذ اللي كانوا بهالمشروع هذا طوروا اب من شان يعني هي مماثله للاب يلي عندنا اياها بالجامعه بإيرفاين، عشان التلاميذ اللي بالجامعه يكون عندهم دليل للجامعه من ناحيه البرامج التعليميه او الخرائط الجامعه او امكنه مثلا المطاعم او غير اشياء يعني بيحتاجوها بدراستهم اليوميه بحياتهم اليوميه بالجامعه. بقى التلاميذ اللي بالمشروع هيدا طوروا برنامج على الاندرويد اب، يعني هو برنامج الاندرويد، اضطروا يتعلموا كل لغه الجافا وطريقه كتب البرامج بالجافا الاكليبس اس دي كي، وعملوا البرنامج كله من اوله لاخره. So, to say in English, they developed actually coded, debugged, and tested an application on a Motorola Zoom tablet that we purchased for them as part of the program. So that was the first project, and you saw a brief demo of that in the video that we showed before. The second project, basically, as Dr. Ahmed mentioned briefly, was an Android app that was for prayer time calculation and for finding the Qibla directions. يعني هذه كانت كمان ابلكيشن للاندرويد لبرنامج الاندرويد عشان تشوف مواعيد الصلاة واتجاه القبلة مشان الصلاة. This was developed by 2 team members, and again, they went through the whole procedure. They did not know how to write in Java, which is probably one of the most popular computer languages today. So they learned it. Now they had a good basic from the School of Computer Engineering and Science, from the College of Computer Engineering and Science, and so they were able to learn it quickly. And then they used this language to program the tablets and test it. And so you can see here the project demo that they did. And they actually used this app for their prayers. Now, when the students left, we didn't want them to lose touch with the hands-on philosophy that we embrace in the University of California at Irvine. So we also gave them, as a parting for each group, a embedded systems board that they can use to develop applications once they're back in SAU. And so this is something that they can use to develop. It runs Android or runs Linux operating system, so they can use it for their projects or even later on. So As an outcome, both teams completed their project successfully. As Dr. Ahmed mentioned, they improved their English skills, and I was feeling that as I interacted with them. We had actually student mentors that some of them spoke Arabic and some of them did not speak Arabic. And the students from SAU were comfortable interacting with both mentors very comfortably at the end of the term when that they spent at UCI. And in fact, we actually were so pleased that we encouraged some of those students to apply for graduate study at UCI. And we hope that we can, in the near future, see their application in our database soon. So this is as far as the projects with the College of Computer Engineering and Science. I'm going to talk briefly. We had a lunch yesterday with some of the deans, and there seemed to be a lot of interest in accreditation. So I thought I would put in a few slides about accreditation and our accreditation work. We have, as was mentioned, we have several programs in the School of Engineering that are accredited by the main accreditation body. In this case, it's ABET. And particularly in my department, EECS, we have 3 programs that are accredited. And this is electrical engineering, computer engineering, and computer science and engineering. I act as the lead person for 2 of these programs, computer engineering and computer science and engineering. And these are very different programs because in accrediting them, when doing the assessment policies, we actually were using 2 different philosophies. First, I'll just introduce ABET. It's an accreditor for university programs that manages applied science, computing, engineering, and technology. Of particular interest to us is the Engineering Accreditation Commission, EAC, and the Computer Science Accreditation, which is the CAC. Now, one of our programs is quite complicated in the sense it is accredited by, or it has been reviewed by 2 of these committees, because computer science and engineering spans 2, EAC and CAC. So that was a challenge for us to do, to go through the accreditation. Now, one of the main components in accreditation is 2 sets of objectives or criteria or metrics that we use to evaluate students on. One is called program educational objectives. And this is the long-term objectives, broad statements about career and professional accomplishments that the students are expected, or graduates are expected to achieve after a few years of their graduation. There's also the student outcomes, which is what the students are supposed to or expected to know as far as ability and knowledge at right around the time of graduation. Okay? So one is a long-term and the other one is a short-term. And there's a curriculum review process that is based on a feedback loop where you do a continual improvement of the program. This is based on steps. One of them, the first one is assessment, where we collect data on achievements. And this case is composed of surveys, of course assessment reports, and a direct survey to the students. There's also an evaluation that takes place for these data. And then recommendations are carried out to whatever accreditation committee controls each program. There are recommendations that are made, and based on these recommendations, you make changes to the course or goals or the process itself. And then you reassess, and hopefully you're improving the achievement of the student outcomes and the program educational objectives. So this is a big picture with everything tied together that essentially involves the constituencies of the program. These are the professors, the students, and the employers of our graduates. So examples of program educational objectives. I'm not going to spend too much time on this. And basically, focusing on one of our programs, the CSE program I mentioned to you, it's assessed by both committees, CAC and EAC. And the problem is each committee has its own set of student objectives or expectations from students. So what we had to do is come up with our own set of outcomes, indicators, and then from that, map it to each committee's expectations. Now, as far as assessment tools and methods, we use course-embedded assessment, which essentially is taking questions or homework problems and things like that from the students' work, and then use those as our data and see how many of the students achieve those outcomes. There are also rubrics that we use for assessing students in their senior design project. Okay? And so something like this would end up taking place, where each outcome, in this case you see on the top A through M, is assessed, and then the data is collected so that you have a global picture on how much students are achieving in terms of their knowledge by the time they graduate. And then we use this data to drive our improvement process. Computer engineering is a different beast. Essentially, we have maximal coverage, whereas in computer science engineering, we use a limited set of courses. In computer engineering, we're using all the courses to be assessed. And I understand there is a process here where you're discussing whether to use one method versus another. So there are advantages and disadvantages for each method. There's also a continuous improvement process. This is criterion 4. And essentially, as I mentioned, this essentially is critical to plan, implement, and properly document such a process. So it's very important to document that process and have a clear set of steps that were taken to achieve that continual improvement direction. Now, actually, I have to point out that recently ABET has changed some of their practices, actually, as of last week, where they are less stringent on some of those continual improvement assessments. So that might make the job of doing ABET accreditation a little bit easier. And this applies actually to next year's programs being reviewed. So in summary, ABET may seem like a long, complicated process, but it is useful for programs to keep up with the progress, and it essentially helps in improving the curriculum and the courses, and that would enhance the program's reputation. What's very important is to maintain a good level of faculty involvement. So with this, I would like to thank you for your attention, and later in the 2 days we've been spending, I'd be happy to spend time with your faculty or your administrators and talk about this process some more, if you like. Thank you.
Thank you for this presentation. If I have a small question here, the School of Engineering and the School of Computer Science, they graduated only one batch of students. Do you recommend they could go for accreditation now, or should they wait till they have more, like 2 or 3 batches of graduates?
I think it would be useful to at least go through a mock review process in the beginning and have a self-study report prepared and reviewed. I am not sure, so having been in a university where we graduated many classes, I'm not sure if ABET would make a difference between one batch graduated or not. Perhaps Dean Gregory might have input on that. But I think it's very useful. It's extremely useful to have a process in place that is well documented. Whether you go for it now or later, start the process now while you're fresh, and don't delay it.
The requirements say you need to have one. You need to have one graduate.
Yeah.
So, yeah. So if you have that, if you have that, you've met that standard. And so I would pursue, as Professor Fadi said, I would at least pursue the process of having a mock with you, at least.
Have stopped doing it.
Yes.
Yeah.
So I would start.
Thank you again.
I think when I visited you back there, you showed me a room which you assigned somebody to take care of these files and ABET work, and you've been selected as as one of the reference. Please illustrate that, please.
Thank you. It's very kind of you to mention that. One thing that we pride ourselves on in the School of Engineering in general, and in my department in particular, that we have extremely competent staff members from the school level all the way to the department level. that have gone through the review process many, many times and have achieved stellar results. I'm proud to say that our computer science and engineering program was accredited for the first time. We went through accreditation, and it is not it is not a secret to say that at their conference, at their ABET actually put 2 self-study reports as examples of what to do as a template, and ours was one of them. So, and this is all thanks to the work, support of the school and the department we had. So that process has been going on for many years, and we are becoming, let's say, old pros at this.
It's still morning. Good morning. I think I was supposed to present my talk this afternoon, but since we have some time, I'd be happy to do it now. My name is Michael Green. I'm the chairman of the Department of Electrical Engineering and Computer Science at the University of California, Irvine, and I'm very happy to be here. Thank you very much for your kind hospitality. I'll be spending just a little bit of time giving you a general overview of the department at UC Irvine, and if you have any questions, feel free to ask me. In fact, feel free to interrupt me if you have any questions while I'm talking. So I'll present the academic programs. I'll say a few words about our accreditation process, and then I'll tell you a little bit about our research as well. So here's an overview of our department. We currently have 32 full-time faculty. In addition, we have 23 affiliated faculty. That is, there are some faculty members in other departments in University of California, Irvine, who work with us in some way in helping teach or advise our students. Our current enrollments, as of last year, over 450 undergraduate students and almost 300 graduate students. Those numbers are going up very quickly every year. And then among the undergraduate students, 139 of those are computer engineering majors, 77 are computer science and engineering majors, and 240 are electrical engineering majors. And similarly for our graduate students, 120 are computer engineering and 170 are electrical engineering. So with a large number of faculty, we have a very diverse group of strengths in research. I won't read them all to you, but you can see we have a large number of interests going all the way from computer architecture, embedded systems, to analog RFIC design and nano and biotechnology. And just here's a few accolades and awards that distinguish our faculty. We have 2 National Academy of Engineering members. We have a large number of IEEE fellows and fellows of other professional organizations within the department, 3 highly cited researchers, and 8 faculty who have received very prestigious Young Faculty Awards. One is called the National Science Foundation Career Award. That's only given to faculty within the first few years of their career, and a similar Young Investigator Award from the Office of Naval Research. So young faculty are really excellent in our department. Here is an overview of the 3 undergraduate programs in our department, similar to what Professor Fadi had mentioned. So our electrical engineering degree has been accredited continuously since 1968, and we currently offer 5 specializations in that major. So students in the electrical engineering major can choose one of those 5. We have a computer engineering program, which has been accredited since 1994. And then our newest program, Computer Science and Engineering, has been accredited, as Professor Fadi mentioned recently. It's actually officially since 2009. Okay, I'll say a few more words about our accreditation, just to add on what Professor Fadi mentioned. And I think many of you in this room are familiar with this, since I understand you're going through your own process now. And so you may be familiar with the set of criteria that ABET uses in order to determine the accreditation. There are 8 overall criteria. Most of them are fairly straightforward. So the ones I'm showing here in white, for example, criterion 1, students, simply verifies that you're mentoring the students properly, that the students understand the requirements are, that prerequisites are enforced. Criterion 5 is the curriculum. Are you offering enough math and physics and other kind of specialized courses that give rise to a good engineering curriculum? Are your faculty, criterion 6, are faculty well qualified? Criterion 7, do you have the proper facilities? Do you have enough lab equipment? And finally, Criterion 8 is the university giving enough support to your program. So those are fairly straightforward criteria. The other three criteria I show there in yellow are the more difficult ones. I won't say too much about that because Professor Fadi's already gone over those, but those three criteria, 2, 3, and 4, tend to be the most challenging for faculty. So one is coming up with the program educational objectives. I'm going to be talking here just about the electrical engineering and computer engineering programs because those are most simple structurally. They only have one accreditation. And so what I'm showing here are our program educational objectives for each of the two programs. And as said before, these are what we expect our students to be able to achieve a few years after graduating. And so it's these objectives that help inform our entire program. The student outcomes, also as Professor Fadi mentioned, are the skills or abilities that students should be able to know and to demonstrate by the time they graduate. And those are shown there. And then finally, Criterion 4 has to do with the continuous improvement, making sure we're following those objectives and those outcomes. So with this Criterion 4, we have to regularly use appropriate and documented processes for assessing and evaluating all of those things. And without going into details, some examples of assessments that we use for our program educational objectives and our student outcomes include scores on certain individual problems on an examination that we think really shows their abilities in certain areas. Sometimes we use evaluation using a certain type of form called a rubric. And for other kinds of assessments, we use surveys of students, alumni, and local industry. If you have any questions later on about these details, I'll be happy to tell you as much as I can about them. Okay. We have we support three graduate programs in our department. One is the electrical engineering concentration, in which we offer 2 plans of study, one in circuits and devices, the other in systems. We have a computer engineering concentration, which has 2 plans of study, computer systems and software, computer networks and distributed computing. And we have a special graduate program which we offer jointly with the other School of Information Computer Science, which is called Network Systems. So students have a large variety of programs to choose from in our graduate program. All of our graduate programs are structured more or less in the same way. We have both master's and PhD degrees. For students choosing a master's degree, they have 2 plans. They can do a thesis option, in which they take about 8 regular courses, plus they find an advisor and they work on an MS thesis. And for them to graduate, they have to successfully complete that thesis and have it signed off by a committee in the department. Or a second plan, this is especially of interest for students who may be working full-time but want to pick up a degree later on. We have what's called the comprehensive exam option. In that case, there is no thesis required, but they need to take more courses, 12 lecture courses altogether, plus some kind of comprehensive examination. And then our PhD program has a number of steps. By the first year, entering PhD students must finish a preliminary examination, and that tests them on basic knowledge in their field. There is some teaching requirement of all PhD students. Often it's satisfied by being a teaching assistant for a course. A couple of years after they start, students need to finish what's called a PhD qualifying examination. That is where they present their topic and the research that they've done so far to a committee. And then finally, when they're done, they finish their dissertation and they do a defense. Okay. And then the last part of my talk, I'll tell you a little bit about the research in my department. So we roughly have 3 main thrust areas in research. The first is circuits, devices, electromagnetics, and nanotechnology. The second is computer engineering, and the third is communications and signal processing. And I don't have enough time to go through everybody's research, so what I'm going to do is give you kind of an overview slide like this for each of the 3 thrust areas, giving you an idea of what the faculty in each of these areas does, and then I'll give you kind of a sample of one person's research. So the first thrust area, circuits, devices, is roughly divided into these 6 sub-areas. between circuits, MEMS, photonics, microwave, nano, and packaging. And Professor Mark Bachman, who's a younger faculty member of my department, does work in MEMS and biotechnology. So here's just a sampling of the kinds of work he does. So he works in micro-integrated circuits and systems, electronic health systems, and computer-machine human interface. Excuse me. And here's just some illustrations of the kinds of things he does. The second thrust area is in computer engineering, and that's roughly divided into 3 sub-areas: hardware, embedded systems, and software, where they have some overlap. And a good example of the research we do in computer engineering is Professor Rainer Domer, who works in embedded system design. So one of the interesting challenges in this field is the idea of designing very large and complicated systems that may include electronics, mechanical, and other kinds of things. And what's the best way to model and verify that all these different types of systems will work together properly? So Professor Domer comes up with different kinds of modeling languages that allow this to happen. Okay, and finally, the third thrust area is in communications and signal processing. We have a number of sub-areas here, including computer vision, communication, information theory, wireless systems, network reliability and security, and detection and estimation theory. And the area that I'll highlight here is that done by Professor Jafar in communication and information theory. And what he's been looking at are how can you extend the capacity of wireless networks? Is it possible to get even more bits per second than what's thought to be possible now? And he's come up with a number of different ways, and it's far too complicated for me to go into here, but he's been able to show that you can get much larger capacity by using appropriate techniques than ever before thought possible. Okay, and here's a little bit more about what he works on here in network coding. And that is just about the end of my talk. Are there any questions or comments? Yes?
Thank you so much indeed for your good presentation. My name is Dr. Abdulwahab from my question is that I'm a bit interested in the quality of education in general. I know there is something called curriculum mapping, where you map your objectives to your outcome. So my question, what time do you think is the right time to do that? Is it the beginning of the academic year, or you have to wait till graduation of first batch, especially for a new established college? This is the first question. The second question is about the curriculum committee. To maintain the quality assurance and the quality control of education in general, you have to have such a committee. And I'm wondering, what time do you think is suitable for self-assessment report that usually raised from this committee be a suitable time? Is it at the end of the academic year, or you have to plan in advance?
Okay, thank you. Those are 2 very good questions. Let me see if I remember them correctly. The first one was, how do you map the student outcomes into your program educational objectives? And the second, and when should that be done? And then your second question has to do with
the self-assessment report.
Yes, which is part of the accreditation. Okay, and the second part has to do with when should the curriculum committee start working on this report. So I think for the mapping, and this is getting into details, so I'll just say a little bit, and then maybe we can talk offline in more detail. I would say that can really, that mapping can be done any time, but the sooner the better. I'm not sure there's an optimum time of the year to do that. I think probably whenever it's most convenient for the faculty to get together and talk about this. I personally, I haven't seen that have a large effect on the actual curriculum itself. I think most of us know what the students need to learn. So I would say to do those kinds of details that are required by the accreditation, perhaps during the summer when things are a little bit quieter, might be a good time. But other than that, I don't think the timing is terribly critical. Of course, it has to be done before you start finishing the report. The second question having to do with the curriculum committee, I think I'm going to answer in the same way. One of the mistakes we've made more than once is not worrying about putting together all the details, and then a month before the report is due, all of a sudden we're running around trying to get all the data as quickly as we can. So my suggestion is this process goes much better if you make this nice and calm and consistent, and just make sure you get some data, enough data every quarter, so that when you put it together, it becomes fairly easy and straightforward. I've also found that as long as the faculty understand what we're doing and why, and if the curriculum committee makes it as easy and simple as possible for the faculty teaching the courses, I found that the faculty are generally very cooperative. If they understand what we're doing and why, then that makes the whole process very easy.
I will tell you our experience in doing that. We usually double blindly, where we have the report from the faculty before they grade their results. So there is no bias. And at the same time, the student will release their feedback before they get their results, so they will not have bias about their faculties. I don't know if it's right, it's not evidence-based, but at least this is our experience in the past to do that. And I hope it's going to be
Indeed, yeah, that's a good point. I could probably, yeah. You could hear a lot from faculty about what they think about the student evaluations and the relationship to grades. That's a very interesting conversation. Okay. Well, thank you very much for your attention.
Thank you all for coming here to this workshop. And we are going to have a short break for Salah, inshallah. And for the team, inshallah, we are going for a short tour in this college. Thank you so much.
Three blades. Let's start with this blade. This is a background about the irrigation system and Al-Khat area. This is a canal heading downward to the east. This picture taken by American geologist who published his PhD in 48 about Al-Khat district. Glenn Brown. This picture, you can imagine the situation here. This is 2012, where the channel destroyed. Some historians they back this channel to medieval, and some of them they back it pre-Islamic history. It's back to 2000, Romanian time.
So there's water under this?
Yeah, you can imagine this is depiction for the water canal. This is the canal underneath, and this
opening hole.
This is the opening hole is for cleaning the channel. So this is the water table, and this is the canal, and the hole is decreasing eastward. So imagine this one. I mean, there is no scale, but we scale it by figuratively. You can scale it. This picture taken by Glenn Brown in 48, and the scale is the man is standing here next to the canal, and the water is running downward. So this canal is down there, and the man, I mean, I don't know who is digging this, and there is no date for the canal. So I'm still searching for that.
But the water is coming from where? And
It's from the mountain. It's from the mountain, from the spring well. Spring well next to the mountain.
And this is no longer exists?
No. It's right out.
Actually, you're answering the question that me and Dr. Derek were talking about on the car here. Where does the water come from for the irrigation of the dates and the dam? So this is a very timely presentation.
It's coming from the aquifer.
So what do you do now when the aquifers dry up? Where do you get the water?
More deeper. We go more deeper.
There is no alternative. Even the salinity is very. So let's back. If we go to the second blade, this blade is showing the spring well next to the city area. So this spring well is natural spring well. This is the water in 48. And now it's dried out. You can't imagine there is no water at all, and there is no place for this even, for the boundary of the well. This one is still, it can be shown. You can visit it and you can see it, and there is no water. But it's a hole with 100 meters deep, and there is no water. We are trying to just show it as a historical place.
And this is near the castle of King Abdulaziz?
No, King Abdulaziz is forward. Yeah, this is not far. It's far away from it. It's about 2 kilometers. This is an oblique view taken by airplane for the area in 48. The city is now expanding in this area. The black is a farm, and this is a canal coming out from the spring well. If you see this black spot, this is the spring well. It's a cast.
Is that this one here?
Yeah, this one here. And this is Glenn Brown, and this is Mr. Clary. And they were well known for the people of Arfan. Yeah, highly respected for the people of Arfan. They served a lot.
But tell them that the Khali is the first place to be used as for like the Shah.
Yeah.
Because
they started with the Iraqi people in 1930. After that, King Abdulaziz asked Aramco, the oil company, the American oil company, to supervise the water irrigation system to this area. Let's move to this channel. It's a small river, used to be. Pump through this one, the spring well, to the project, the agricultural project in the eastern area. The length of this canal is about 20 kilometers. At that time, most of the people of Arfan was using this as a resort, tourist resort, or the resort, or they can use it as a pleasure area or something. Let's move this. This is the first. This is the first farm established in Adinam area with mechanics, and this is the plant for that. This is it used to be a traditional farm. Then after the American came, they moved it to the farm using a new machine and a new process. Back to 1972, this is the first image published by NASA for the first satellite image published in 1972. The resolution is 80 kilometers, and it's very coarse resolution, but showing the Al-Khalj area at that time, where the red is the farm, and the city is limited to, confined to the King Abdulaziz Palace. This is the map showing that.
Big lands that consuming very low amount of water, and as well very tolerant or resistant to salinity, because water here high saline, and as well consumed to get it's a problem to get the water available. So we decided to go for lands that consume very low amount of water, which is saffron. And the critical point for saffron is that the biggest country in the world consumes saffron is Kingdom of Saudi Arabia. And the country do not cultivate it, not just produce it, do not cultivate it. So we work on how to get it cultivated. The problem for this plant is tri-blade, which has 3 feathers or 3 barrels, which is unusual in plant kingdom. And the idea also it's not cultivated by seeds. So we should look for corms, which is vegetatively propagated. And what we did here, we work to adapt it, to cultivate it here. And please, you can see the production of this plant last year in 2 different locations, 20 kilometers between both of them. And this, you mentioned, it's very expensive because one flower produced only 3 stigmas, which is 0.05 gram fresh weight. So that's why it's very expensive. 1 hectare produces about from 1 to 4 kilogram, which is calculated for 1 kilogram minimum 2,000 US dollar. That's why it's expensive. More of that. Yeah, exactly. In most literature, it's red gold.
Yes. Actually, you had it in your copy this morning.
Yeah, that's why I'm telling you, biggest consumer in the world is KSA. And as well, it's labor hand. Till the moment, even in Spain, they do not have a machinery cultivation, machinery harvest. All process from cultivation to packing, not packing, harvesting and separating is hand labor. There is no machinery for this.
And you discard the flower part.
That's what. Yes, only we take the female part, which is the stigma.
Right.
But the others still, it's our strategy plan here to get it's the H index, which is used in this plant, only 0.5 of the entire plant, which is this weight of the plant. But the other things, of course, had a value of medication, or we can use it for other things. But till the moment, this is the main goal. And there are 2 different places in Narjan place, which is about 20 kilometers away from here, and in Yamama, which is also another direction, 20 kilometers away from here. And the other idea that we go...
The flowers come out usually at the beginning of December.
Yeah,
so,
expecting this week.
Hopefully we
But the weather is different. We had a very heavy rain 2 days ago, the last 2 days, and of course it will affect on the plant.
So how many are you expecting to grow?
It's 1 acre is equally just
around. And what we are doing to get these corms in vitro, so we can in the plant get segmented of this mother corm and micropropagated in vitro. And we have maybe 75% to get a protocol in the SAU conditions. I mean conditions, water quality, environment, EC conditions. All these environments should be, inshallah, adopted in our laboratory here as well. Yeah. And the idea, we are also working on another plant, which is cardon. And this plant is tolerant to salinity. And this plant used many years ago as a capsules, syrup, tablets. It's a wild type of
artichoke.
الأصل البري بتاع نبات الخرشوف. مشهور. It's very famous in California, globe artichoke. The biggest commonly produced seeds in Imperial Valley.
And this is first time growing it in Anakhad, in Saudi Arabia.
And when we see this bees visiting the flower, we get the impression that we will get a seed produced in this environment. And that's what we in fact get. We get the seeds from the plant already grown in harsh conditions, environment conditions. And also we do use another technology, which is magnetic field. We treat the corms or the seeds with magnetic field with different power, millitesla, or I think we work only with millitesla, not Tesla, it's very high. We do not have that power for magnetic field. Different timing, and we got success that you can maybe see the differences, number of shoots, leaves, all these are treated with magnetic field different time. And
tell them about the published papers. We haven't sent it. because you notice the roots of the plants. It's heavy. After them, we treat it by magnetic field. So heavier than the ordinary one.
What's the purpose of the magnetic field?
Propagation and to enhance the growth parameters for the plant. As you can see here, as mentioned by Jaidi, control has very less amount of root system. What does it mean if you have a good root system? It means healthy plant. It means high yield. It means good seeds later on. It means good, healthy plant. And in fact, NASA do that in their space program for planting seeds in space.
So I'm wondering, is the rain pattern here light rain or flash floods or something?
Easy.
Is the rain pattern light rain or flash floods? We get more flooding rain or light rain?
In fact, my experience here for years, so just rain. But flooding, we didn't experience flooding here. But I hear 20 years ago it was a very big...
Sporadic. We haven't experienced any floods. Even in Al-Khard we have floods 7 years ago.
But raining in Arabian Peninsula is not that much.
I know the rainfall is less than 100 mil.
Maybe, but also a couple of minutes in the other case. What's the
Prince? This is the crown Prince Salman, the university named after him. So we are very pleased to handle him the first production of our farm. Yeah. This is
that saffron?
Saffron, yeah. And we present it for him.
As
a gift. It's 120.
How many kilograms?
It's
many grams. How many grams? Not kilograms.
No,
it's not kilograms. Just
this is
our concept.
Also, this is our director. He's very busy now. Not even in the
fact,
this is the mayor of
in fact, I should also highlight that all the running apparatus here or machines are from the fund we attracted from the Sheikh site. This where we're doing the magnetic field. I can show you very quick. We just designed an experiment.
Oh yeah, I see you have the field in there now.
We just designed an experiment for magnetic field to cultivate it in the Yamama area because the water salinity here is about 4,000 ppm. Very high saline water, 4,000 ppm. And we treat it with different, maybe 4 minutes later it will be over to exchange of the form of the saffron, and we cultivate it in vitro to get from each segment, hopefully later on, a mother cord, which can be available to the grower, so we can spread cultivation of this plant in the country. Because the issue here, Celtic carbide, is a plant propagation material. There's no seeds from this plant, but only the corms. And to get the corms, it has to be cultivated many years in a big area. So what we do, we get this virus-free corms from the in vitro and distribute it to the interested growers to cultivate this plant.
I was wondering, is there any research to genetically modify it so that it is more amenable to grow here?
Which is moringa. North east of the kingdom, they have another phenotype, a genotype from this plant. And our colleague, engineer Anas, will give us about this plant, and I will translate very briefly in English, please.
بسم الله الرحمن الرحيم. نبات المورينجا نبات حولي يوصل طوله مثلا حوالي 5 أمتار في السنة. يعالج أكثر من 300 مرض. يعمل برضه كغذاء للحيوانات.
So let me translate it. This plant is a tree. Height is 5 meters long, and from architecture it cures more than 300. We try also to make a collaboration with the Marai company, but it's very hard to attract them to come to us. And we successfully
وبدأ يصنعوه برضه كشاي منتج من الورق نفسه بينشف عبارة عن بودرة كده وبيتعبى تعبئة نفس النبتة.
So this is the seeds of the tree. It's marble. And then we got the leaves from the tree, dry it, powder it, and this already available in the market in this form or as a tea bag. And they use it for diabetes and diet system, mainly for losing weight. And we work on that to acclimatize it to the environmental condition here.
Okay. Thank you very much. We have
Thank you. Yeah.
This is a very popular plant in the Philippines.
Two presentations after this. We are going to have Dr. Drake Dan Rankins to present about UCI, and also after that we are going to have Dr. Snady to give a presentation about Salman bin Abdulaziz University. So Dr. Drake, please.
Thank you, and I add my appreciation to my colleagues for the invitation to come and describe a little bit mechanical and aerospace engineering from UC Irvine. Professor Green was supposed to give the talk just after lunch, which is the most difficult one. Everyone's had a nice meal, relaxed, but he got to go ahead of lunch, so I'm supposed to liven up the audience, make sure that no one gets too sleepy. So let's see if I manage that. This is a photograph of where our department is. You've seen some aerial photographs, but this one is just to give you an idea of the Henry Samueli School's Engineering Gateway building. And so mechanical and aerospace engineering offices are in this cross piece here. Our laboratories and many student research offices are here, and then electrical engineering and the microfabrication facility is in this side. I wanted to also put up that the mission of the school, and you saw a little bit about this, but it really is about educating students at all levels. And there are three main elements in that mission: educating students, but creating a stimulating community in which those students are educated, and then discovery, creation, and service. The first part is kind of the undergraduate program or the curricula, and those are the things that you have shown some interest in and you're building here in your own programs here, and I'll talk a little bit about that. The creating a stimulating community, part of our interchange is about that stimulating community, so getting people to come in both directions, but it's really a community of scholars, and so this means getting people to think in different ways from different places at different levels, and having all of those people interact is what our goal is. So this creation of a stimulating community is an important part. And then the last part, discovery, creation, and service, refers to the research role. And Dean Washington identified that a major responsibility of the faculty at UC Irvine and all the UC campuses is a research mission. And the reason that that's important is that we often think about what is special about education in a research university. What is different about getting your regular education when you have a research component as part of that? Even if the students don't participate in research directly, the research mission of the university filters into the educational requirements of the students, both by giving them access to the very best laboratories, giving them access to graduate students who are doing cutting-edge research and new discovery, and giving them access to faculty that have that mindset that let them create. So it's a different kind of engineer, and it's a different kind of environment, and it's something that you might think about. How do you create that stimulation that's part of research in your university? So here is mechanical and aerospace engineering, and I put this up really as a kind of apology because mechanical and aerospace engineering covers so many fields that you could you can sort of combine it with anything. In fact, we do a little bit of electrical engineering, we do a little bit of computer engineering, we do a bit of civil engineering, we do a bit of biomedical engineering. That's all within the same framework of mechanical and aerospace because those same fundamentals apply across all of those engineering disciplines. And so we have to pick and choose amongst all those, and this is what the faculty said that they do, okay? So there's continuum, power and propulsion. Well, you'll see these same kinds of things in various other engineering fields, so this isn't really realistic. What is real is that we have 24 faculty members, and we have 2 majors, plus an MS and PhD. We have about 800 undergraduates now, and 135 graduate students. Here are those faculty. And see, I look the same in this photo. These photographs were mostly taken when the faculty first started at the university, not what they look like today. So if you go to their website, you have to sort of do a mix and match to figure out who's who in these pictures. But we just added these 2 new faculty here, one in energy systems and the other one in micro and nanostructural materials. And you see Dean Washington is actually also a member of our department. So we have this odd relationship where he's the boss, but also he's supposed to do what I say when it comes to teaching. We'll see how that works out. On top of that, and this is all about the stimulating community, we have the joint appointees, which are affiliated from other departments. We have adjunct faculty, including National Academy member in aerospace engineering, and we've just added a new member, that's why his photograph isn't here, Jay Kudva from NextGen. Scott Samuelson, one of our senior faculty members, just retired, but he's very active, still runs a center in energy and environmental systems. So this is the way that we divide up what are more thematic areas in the department, and to give you an idea of the kinds of range of things that you can do. And this is A, B, C, D, E, so it may kind of make it easier for us to remember, but aerospace and defense, biomedical, controls and robotics, design and manufacture, and then energy, transportation, and the environment. Those are the sort of main thematic areas if you package the faculty up. In aerospace defense, here are some example things that are going on. Aero-optics, some MEMS gyroscopes, mixing in jets. These are all fundamental research areas that students at all levels get involved in. In biomedical systems, it's some smart drug delivery. We also do biorobotics. You saw an example of that in the dean's presentation. In controls and robotics, and you see there is some overlap, we have some self-stabilizing robots. We have some smart systems for power generation, and then these are some kinematic results here. In design and manufacturing, it's mostly smart materials and nanostructured materials, building components one droplet at a time. So these are fabricated from individual droplets that you can grow complex shapes, sort of 3D printing, but using metal instead of plastic. In energy, transportation, and the environment, we do a whole range of things, including air-sea interface work, jet mixing, and then combustion and combustion science. These are some droplets that are breaking off of a jet here. So all of these, the power and energy systems then, and the relationship of those to the environment are what the energy, transportation, and environment component is. So if you package the faculty based on the kind of fundamentals that you do, you get one picture. If you package it in terms of the kinds of applications, you get another picture. And if you think about it in terms of more generic groupings, then you get yet a third picture. And these are all saying the same thing, that it's very difficult to divide what you would call specialties. And so as you describe an entire department, it turns out that it really is the collection of expertise of the faculty that make that department up. And so if you change the faculty, you get a change in that expertise. And we respond very specifically to the changes in that expertise. So at the moment, so here are those same people put into those other boxes, and you see that we're grouped very heavily in this fluid and thermal sciences at the moment. We're starting to add more people here, and so you'll see shifts and changes of topics as the people change. So this is just another grouping, and so these are the applications in the center, and all around the outside are then all of the people. So again, just as a reminder, I mean, it's people and applications. Here are some biorobotics. This is the individual, Dave Rinkensmeyer, who leads that. And it's all about helping people get rehabilitated using robots to assist them. Scott Samuelson in the energy system, you heard about the hydrogen station, but his work is much broader than that, including gas turbine combustion and also fuel cell vehicle and vehicle deployment. Mark Madu is doing smart MEMS, both biomems and CD microfluidics. And Satyat Lurie is our best known faculty member. His resume is a 200-page book of publications and so forth, all in the area of structural mechanics. So basically, all the code that's been written for structural mechanics has come out of some of the work that he has done. And so these are just 4 individuals that then sort of set the directions in the research environment for our department. But the undergraduate education is not so sensitive to that. The undergraduate education is now something that's agreed to. You are all looking at accreditation. And so that's a kind of formalization of what it means to be a mechanical engineer, for example. The kinds of things that mechanical engineers know around the globe are meant to be fairly similar. There are some variations, but they're meant to be similar. And so all undergraduate education is sort of made up of these components. There's some basic math and science, some engineering expertise, technical skills. These include computers, electronics, machines, some machining, and then engineering design. Now, the way that you weight these things depends on your institution. And this is a sort of typical program of study, and this is not accurate at the moment, but it's just a kind of 4-year layout that maybe some of you have studied. But the idea is that you do your basics in the first year, kind of spreading into the second year, begin to do a little bit of engineering stuff by the 3rd year, then you do very core engineering material in the 3rd year, and in the 4th year, you're applying these things in advanced applications. That's true, I think, of most of our majors. And it's quite a common engineering strategy. We're asking whether that's the best strategy. Is it a good idea to make people wait to do engineering until after they've built these basics or not? And so we are starting a freshman program where we're allowing students to do more design early in their program to kind of motivate them to study the other basic material. So here's a pictorial version. I'm sorry if you've seen this before, a couple people have, but this is a pictorial version of a UCI. Anteater is our mascot, so that's an anteater. Before they begin the program, they go through fundamental science and engineering, and they end up now in the UCI colors, but they have their components sort of mixed up. So they have improved their basic understanding, but they don't know what to do with that understanding. So then we give them technical skills. They go back through our transformator, and they become more recognizable. They still have a few things out of place, but they are still, but they're still growing their skill set. Then we give them design training, and this is a kind of typical multidimensional design training experience. And these are some examples where they do, these guys built a small miniature turbine engine. This is an electric go-kart. This is a self-stabilizing flying saucer. It has 4 motor propellers here that stabilize it, and then a stair climbing wheelchair. So these are sort of typical projects that you would use as a mechanical engineer to motivate the kind of basics that you would have learned. And so our question is that enough to make you an engineer? You've done your basics, you've studied the technical skills, you now built one of these little projects. Are you ready to be a functioning professional mechanical engineer? And we don't think that you are ready. And the reason is that there hasn't been a demand of your skills that are tested outside the university environment. That is, we can fool ourselves to thinking that you've done a good job on your design project if we just talk to you and you say, yeah, it kind of works, and this went up the stairs and it broke right after this photo was taken, in fact. So the design was not very good. But still, that's sufficient in most cases. So we're asking for one more step, and that is what we're calling performance engineering, and this means being part of a project experience that's much more demanding than a kind of small project environment. In this case, you design something to meet the performance demands that are outside a faculty supervisor. They're either an international competition or you have defined the performance expectations of your object. So in this case, the UCI rocket was meant to go 12,000 feet, launch this rocket 12,000 feet and do some telemetry. This is an international competition for a formula car. This is a nanosat that's being launched by Boeing, by a grant from Boeing, but is being launched next year, right? And so the performance of the satellite has to meet outside specifications. That requirement is much more stringent than just doing a design project within the confines of the campus. So that's what we're asking our engineers to do now, to concentrate much more on problems that are bigger than any single individual. These are a cargo plane and another international competition. So that means that you need some kind of industry or external interaction, and after that, then you're fully functioning. This is the super engineer that comes out at the back end of that entire experience. So that's our objective as the Mechanical and Aerospace Engineering Department at the undergraduate level, that the engineers would come out with a combination of fundamental skills, but also have been able to demonstrate those in an environment that was challenging, realistically challenging. That's not the end, because because we are a research university, some of the students will finish with their bachelor's degree. They're ready then to work at a company, maybe start some startup companies, go into any other fields. Law and medicine are quite common as secondary fields, but there's also these sort of graduate activities that are available to students from our department. And after a PhD, then of course you get to do all of these fun things. Including visiting places like this amazing university here. Research opportunities in our department include these, and I just wanted to give you one example. These are some photographs from our research labs. This is some Mars landing, so doing some control to get, in fact, the Mars rover that landed used some of the algorithms from our faculty to get within a smaller radius for the landing. This is a laser diagnostic method for making measurements of combustion, little micromotors, a pneumatic robot, and then wind tunnel studies. And I just want to close with a little bit with my sort of notion again about what the research component brings to the overall university experience. And so for me, the research strategy is that it lets you dig into a problem much deeper, very fundamental level, but has some kind of practical ultimate responsibility. So what you see in this photograph here is a spray combustion problem. This is the area that I work in. And so this is a liquid fuel that's being broken up into droplets that ignites and sustains this flame. You have soot pollution as part of this process. You have a stability problem where you don't want the flashback to hit the nozzle face, because the person would not enjoy that very much. This is exactly the same process that occurs in a gas turbine engine. Exactly the same breakup of fuel into droplets, stabilizing the flame, reducing soot and pollution, and preventing flashback onto the surface. So to study that, rather than take this very complicated, chaotic spray environment, we can create droplets that are ideally sized, uniformly sized, and create then what is an idealized spray flame that has the same kinds of characteristics. These things are 100 micron droplets in diameter. So this is the breakup off of a jet of drops. If I light that, I get now a flame that is fully studyable. You can see the droplets here spaced. I have a flame around it. I can now probe temperatures, internal vaporization rates. I can get relationships between droplets that I could never do in a spray, and then relate those up to the more complicated system. We can even take those kinds of combustion problems into space. If you want to get rid of gravity, you can even do a little bit of combustion in space. This is a PhD student that was flying on a parabolic aircraft, And for those that are interested, this is a candle burning in normal gravity. If you put that same candle in zero gravity, the flame becomes hemispherical, looks like this. And then if you apply an electric field to it, you can make it go sideways. All of those kinds of manipulations having to do with a fundamental property that you then apply more broadly is the kind of thing that is possible if you have the whole spectrum of capabilities in your university. And that's what the University of California, Irvine has. And our department also shares in that expectation and responsibility. So we have a little time over the next 2 days. I think if anybody has questions about any of the curriculum or anything about the research opportunities or anything about the philosophy of education, I, like my colleagues, are very happy to speak to you about it. And with that, I thank you.
Any questions?
Thank you so much. I really enjoyed this presentation indeed. However, I'm not an engineer or I have engineering background. We just wanted to ask you about this using the integration of the curriculum result from year 1 to graduated or certified year and compare it to all traditional way of teaching. Have you did any comparison between these two instruction methodology ways?
We have not done a systematic evaluation of the student performance at the end of an integrated experience compared to one that is more traditional. We have only informal, ad hoc kinds of feedback on this experience. And one of the complicated things, as you all know, about education is that not every student is the same, not every student learns the same, not every student is prepared in the same way. And different structures are more effective for different students. A student that is very fundamentally grounded, very interested in mathematics, will prefer one strategy and will be very successful, while another student who is just as good an engineer but thinks more intuitively will respond better if you first lay out the reason for the mathematics before presenting them to them. You can't tell which kind of student you're going to have, and so for us, the model is to give the opportunity for students to learn in all of those ways. We're just trying the freshman experience. Formally this time, we have run a pilot, and we found in that pilot study that we had 25 students that took the course. We found that their performance in their regular classes, physics, chemistry, and mathematics, were measurably improved by having a project to work on as part of that motivation. So that was certainly enough, and there's enough pedagogical literature that says that that is a more widespread phenomenon. So I think it's the more integration you can do, especially for people that prefer to have a rationale for what they're learning, then the more effective the learning model will be.
Yes, can you talk about your experience with industrial relations? I mean, are you going to do the industrial relations for mechanical engineering through the faculty only, or do you have advisor board? We're struggling right now in the process.
Mm-hmm.
How are we going to build the relationship with the industry?
Yeah, so I mean, at the school level, the dean has several mechanisms for relating the university and industry. So I'm going to speak only from the department level. Our view is that the way that you build a relationship is to make sure that there are benefits to both parties, that there's not that you are actually providing something to the industry connection. And so the way that we make the connection is to say we have the brightest students in the state right here, and we can form a team of these very bright students, and we can have them supervised by faculty and someone from your industry and solve an industry problem for you. And if you don't believe it, let's do it. Just give us a problem, but you must stay involved. And to stay involved, we ask you to commit to this relationship. Once you do that, they work with the students, and they find that the kind of dynamic environment that the students create at the company and the kind of dynamic environment that the students create by interacting with the industry then locks the industry in. That company then becomes a partner for Onward. So it was for us easy to say, we have something to offer you. Do you want to join us? As opposed to, will you please help us, right? And that's the kind of model that has worked for us. It gives us a chance to be partners in that relationship. It's still hard. But it's a slow process. You're fairly young and new, and each success will build on itself, and then you will have and when your graduates become participants in industry, then they become feeders back to your system. And most of our industry interactions are coming from graduates of our program. In fact, this interaction, I think, is a bit of an outgrowth of graduates of our program. So students are at the heart of it, and if you do a good job with the students and they recognize that the experience they had at your university is the reason for their success, then the rest will take care of itself after some time.
Are you trying to keep the contact with the alumni? I mean, do you have like...
yeah, so I would recommend that you start the mechanisms right now to keep in contact with all of your students as they, because what happens is, what you'll find it's very difficult to do once they've gone out into the working world. They just become very busy. And so start those mechanisms now. And as for industry, we have, you have something they need to begin with. They're going to hire the students that graduate from your programs. And so getting them engaged as early as possible and having discussions with them that answer the question, what kinds of output would you like to see in the graduates that are going to come work with you? It's very, very important. And so my philosophy on industry has always been, if you ask industry for money, they're going to give you advice. And if you ask them for advice, they'll give you the advice, but then they'll probably give you some money as well.
Yeah, I mean, I think that one of the successful schools that have a close relationship with their alumni, where the alumni actually want to reconnect and stay connected, most always that's the case, because there's a relationship between the student and the university that they spend a lot of time, and that made a big impact on their life. So they are ready to cooperate. It's only up to the institution to maintain the channels of open communication. And so I agree completely, starting early. I mean, I would say that we haven't done a great job in that, and we're trying to recover from the 30 years that we weren't paying attention to what was the most valuable resource of the university, which was the graduates of the program. And there are thousands of them. So, okay, thanks.
Thank you, Dr. Ranking. And now we are going to be with Dr. Fadi for a short presentation about civil engineering.
Just a small correction, Dr. Ahmed. So let me give a very quick presentation here. Dr. Brett Sanders, who is the chair of the Civil Engineering Department, was hoping to come, but unfortunately he had some circumstances, so he could not travel. So he asked me to present instead of him. Now, given that I come from electrical engineering, it will be a challenge, and we will work through this together. But if you have any questions, please let me know. Before I start the presentation, I actually like the question that Dr. Osama asked, because it's very important that you create a very strong interaction between your school and your graduates. So for example, I graduated from UCLA, and UCLA sent me a very interesting statistic. They said that for the electrical engineering program, 80% of their graduates have been employed within less than 80 miles radius from UCLA. So when you think about it, that basically means that your product, which is your students, will most probably be around you, in the area around you, if the industry base is set to accept them, right? So depending on the industry mixture that you have around the university and the way that you feed your students into these industries, if you can create this ecosystem where both the university and the system around it benefit in creating the right curriculum, I think it will grow by itself. And also you have a very strong attachment to the school that you spent a lot of time in, so you would want to be involved in the future of the school that you graduated from. I hope that's basically gives some insight. Okay, so the third department that we'll discuss today is the Department of Civil and Environmental Engineering, and the chair is Professor Brett Sanders. Basically, the department has two main parts: civil infrastructure and environmental engineering. The four research domains or thrusts in the department are hydrology, and given the presentation we saw today earlier, I think hydrology is also one of the main thrust areas here. Transportation, environmental process engineering, and structures and materials. We offer, of course, the standard undergraduate programs of bachelor's in civil engineering and bachelor's in environmental engineering. For the graduate program, we have master's and PhD in civil, along the three main thrusts, which is structural system engineering, transportation system engineering, and hydrology and water resources. We also offer master's and PhD in environmental engineering in the four areas listed. This shows the growth of the program over several years. The top chart is basically your civil engineering bachelor enrollment from 2001 to 2010, and you can see a steady increase in the number of students who enroll in the civil engineering department. Also, you would be interested to see that for the senior is the fourth year, there is actually a very large increase in seniors, and that comes from transfer from our other colleges. For example, we have 3 systems of education in California. We have the University of California system, but we also have Cal State system, and below the Cal State system, we have the college system. So students could go to other colleges and then transfer to UC mid-career. And that's, for example, they would go and spend 2 years in a certain college and then transfer into University of California and graduate from University of California. So that's why you might see a small freshman class, but a large senior class. And the chart below that is for environmental engineering. You could also see a very strong growth in the environmental engineering over the past few years, and that is specifically related to the interest in the US of making sure that we stay green, so essentially that everything we do is safe for the environment and is also, in the same way, not harming society. In terms of graduate enrollments, so we have both PhD and masters, and again you can see the trend that there is a steady growth in both the civil engineering and the environmental engineering students, with again a very sharp leap in the number of students enrolled in environmental engineering over the past few years. In terms of faculty and distinction, we have 24 full-time faculty, 2 members of the National Academy of Engineering, 6 fellows in professional societies, and 4 NSF Career Awards. The Career Award, again, is a very prestigious award, but the good thing about the Career Award is that it gives a large amount of funding to relatively young faculty. So it is essentially meant to encourage young talent to be able to generate research results quickly without having to worry about funding. So that's why it's used as a metric of funding for faculty. We also have part-time lecturers who cover practical design courses. In terms of productivity, productivity can be ranked in many ways, right? So the way we look at productivity is publications and how important these publications are. So in transportation, it ranks in the top 10, hydrology in the top 15, structures and materials in the top 15, and environmental processes in the top 20. There's also many rankings that we're aware of, such as National Research Council rankings and, of course, US News. So in the US News, the Civil Department ranks the 31st on the nation, and environmental engineering is 34th. Then we come to the important question that Professor Osama asked about, which is how do we have affiliation programs with the industry? So there's a lot of civil engineering leaders in the Irvine area, and we try to create this industry advisory board where we would host students. And I don't want to speak too much about it because this is more along Brett Sanders, but I'd be happy to have a conference call between you and Brett Sanders. But essentially in most departments, the way we set it up is that we invite it's called the Industry Advisory Board. So we invite them to our campus and we take their opinion on how the curriculum that we are presenting to our students is that suitable for what they need for their industries. And of course they give us advice, and we try to work that advice into the curriculum that is developed at that time. So every once in a while we would review the curriculum, we would create a curriculum committee, we would review the curriculum and make sure that the curriculum is actually delivering what is required. So for example, in electrical engineering, we have a major rehaul of the curriculum undergoing this year, where we change the structure of the programs that we're giving to students so they are more in tune with what the employers have requested. And we can talk to you also about that later on. In terms of centers, we have the Urban Water Research Center, and we also have the Center for the Institute for Transportation Studies, and both of them focus on local needs. So for example, the Urban Water Research Center research is responsive to the needs of the local water agencies. For example, most of the water in California comes from the Colorado River, so we want to make sure that we have enough reservoirs and so forth. For the Institute for Transportation Studies, anyone who's come to California and been on the 405 will know why we have this center. Essentially, the 405 is the main artery for transportation in California, and it's always jammed. So what they're doing there is trying to figure out how to make it more fluid in terms of management and congestion relief, and also intelligent transportation systems. We also have structures. We have a certified structural testing hall, and that is certified for large-scale specimens. Actually, this is where the civil engineering students got their training this year. So they went into the lab and they were able to do cement mixes and test it and so on and so forth. We also have another very big project that was funded by NIST. It is a multi-university funded project, so it's between UCI and the University of Michigan, Ann Arbor, and a few companies. And this is for real-time monitoring of structural performance. Essentially, you take a big building or a big bridge and you put a lot of sensors on it and you try to measure the structural health of the building itself. We also apply the same applications to water distribution systems to measure, for example, if a leak happens in a pipe, how can you localize that damage and be able to fix it? We also have the Center for Hydrometeorology and Remote Sensing, and I believe, Professor Osama, you visited that center and spoke with the director. Again, projects from NASA, NOAA, and the US Army in terms of satellite-based remote sensing and analysis of hydrologic systems and forecasting. In terms of the faculty, we actually have the faculty divided between the 4 thrusts. So we have 6 professors in the structures and materials thrust. We have 7 professors in the hydrology thrust. And we have 6 in environmental processes. And we have 6 in transportation. So it's basically equally divided between the 4 directions that we have. And this is all I have for presenting the civil engineering department. Any questions? Thank you.
Thank you, Dr. Ahmed Al-Tawil, for substituting your colleague, and you did a good job. Now we are going to have Dr. Abdurrahman Sneedi. We're here to present a project about King Salman bin Abdulaziz University. Thank you.
Hi, good afternoon. My name is Sneedi. I'm here to present the project that is going to be done for the Salman University. The Salman University consists of 4 campuses. First one, which is we are located in Al-Kharj. We have one which is located 100 kilometers from here. Second one is located also 300 kilometers from here at Flaj area. The third one is located at Wadi Dawasir, which is at the edge of the empty quarter at the desert, which is 500 kilometers from here. We are going to present the projects that we have at this campus, which is the total area of the project is 1 million square meter, which is 12, I think it's 10 million feet square. The total cost of the project is going to be 1.5 billion Saudi riyal, which is about, it's going to be $400 million. The project has been designed to separate the movement or the transportation of the pedestrians from the vehicles, so that the students and the faculty will be able to transform from one side to the other without any intersection with the vehicles. We have the first project, which is the community college, which is by the green area. Each floor has 10,000 meters square. That one cost us 100 million riyal. And we are, which is the other building that which we has the administration area there. The second one is the science college, which we are located in now. Then we will have the next project, which is under construction now, which is for the administration college. The second, the building, which is or the third part of the main project, which is the accommodation. We will have accommodation for the students, which will be able to accommodate 1,500 students. That's the other part, which is belong to the faculty, which is consists of 250 units. In our future, in the future, we will have also the computer science college, which will start with during 2 months, hopefully. We also, the designer didn't forget to have recreation area and mini market there, also to have the mosque at the top of the project there. This building is the engineering college, which is the biggest one there, which consists of 16,000 meters square each floor. It has been on 2 stages. First stage is the classes and labs. The second stage is the big lab, which belongs to the structured engineering and design there. Our next project is which belongs to the girls section, which will be just 200 meters from our campus here, which will costing us also about 400 million riyals. We will start with hopefully during 6 or 7 months. This is the location of the Wadi Dawasir area, which is of 500 meters square from here. The thing that I want to mention about this one, we will have another engineering college with this campus also. So we will have 2 engineering colleges with the Salman University. This one, as I said to you, it's at the edge of the empty quarter at the desert there, 500 kilometers from here. That's the end of the presentation. Any questions?
So we're going to have 2 separate campuses, one for the males and one for the females.
Yeah.
Is the instruction going to be shared, or how will the instruction be done?
For medical area, the structure will be sharing. There will be sharing area, but for the other sections, there will be no. Yes.
Would you say your timeline was again to get all of this done?
Hopefully by 7 years will be done. Everything will be ready for use during 7 years. Yeah. But the big thing with the Salman University, it's going to control 4 campuses. These are on a line of 500 kilometers, which is it needs a lot of effort and work to control these things. Okay.
So I think you answered the question that I was planning to ask. So when you have these 4 different campuses, is it going to be an application of what you're proposing for the students to study, or is it going to be a complementary set of campuses? In other words, what you teach in one campus will not be taught in another campus.
No, because what we're teaching this campus will be the same as the other campus, because we are planning in the future to have another universities there to ease the controlling and the education for other students. So we have to make them ready for that situation.
So you have engineering schools in every one of these campuses?
No, we just have 2 engineering schools. Yeah, one here and the other one at the other end. Yes. Mhm. Any more questions? Okay, thank you very much.
Thank you, Dr. Abdurrahman Sneedi, for this clarification about our new campus and old campus. Now we are going to have Dr. Sultan Abutaya from College of Business.
Sorry, they added just my name recently. Your Excellencies, Deans, colleagues, and distinguished guests, Assalamu alaikum wa rahmatullahi wa barakatuh. I am Sultan Abutaya from the College of Business. I'm professor there. Just recently been honored to join the strategic planning team. I'll be with the team of implementation and which is the second stage of the strategic plan. As you see from the executive summary of the plan, that the vision of Salman bin Abdulaziz University is a distinctive university in education and community partnership. If you look at this vision, which came after an extensive analysis of the university internal and external environment, you can find that 2 main factors there: education and community partnership, which will be stressed upon the next 9 years of the strategic plan, which starts in 2012 and may end in 2021. The university mission to produce competitive graduates through internationally recognized education, students with an academic and research environment, distinguished human resources, effective community partnership, and supportive administrative system. As you see in the mission, the mechanisms how to reach this mission appear there clearly. Out of our studies in the or scanning the internal and external environment, we came up with strategic values. We thought that these values really should be instilled within the university: human resources, bureaucracy, and the use of technology. We try to, the coming next 9 years, to stress upon quality, a level of performance that engenders stakeholders' satisfaction and ensures future continuous improvement. We also stress on justice and integrity. All employees are treated fairly and equally. Teamwork and cooperation. Teamwork is very important in a society going toward individualism. We think the scientific work, research, and education needs teamwork among our students and our employees as well. Transparency and accountability, that's in terms the university's performance and response to all inquiries regarding that performance are fairly published. Out of all of that, the university managed to derive some strategic objectives to be accomplished and a set of objectives for each strategic goals. The first strategic goal that the university tries to stress upon is to maintain high standards of support and services provided to students. And as you see, there are 5 objectives can be derived out of this first strategic goal. Do you want me to go through the objectives, or you just look at them? We'll go to the second strategic goal. The second strategic goal, to attract and retain highly qualified faculty members. As you know, a new university like Salman bin Abdulaziz University may be in a desperate need for qualified faculty members. So we are planning to find a policy or a procedure to attract those qualified faculty members from all over the world. Third strategic goal, to develop high quality instructions and create an effective teaching and learning environment. And the fourth, to enhance the university's quality assurance systems and support continuous development. As you know that there are internationally recognized quality assurance standards. The university is actually working now on that, and there is a separate team working on the quality assurance standards for the output of the university in terms of education, research, and community services. The fifth strategic goal, to build an effective long-term communication with alumni and employees. Maybe Mr. Dean, before a few minutes, asked a question about that, and this is one of our strategic goals, is to really stress upon communication with alumni and employers, and maybe what we heard from Dr. Ahmed will be beneficial for us in the future to think about when we come to the implementation stage. The sixth is to continue developing an effective infrastructure for research and graduate programs. That's infrastructures in terms of physical and what we need also for education and research and community services. The seventh is to continue developing sophisticated university infrastructure, and there are some objectives, 6 objectives following this strategic goal. And the 8th is to develop effective local and international partnerships. Partnerships, very important now in a small village that we are living, in terms of community surrounding the university and internationally, like what we are doing with you, distinguished guests. Strategic goal number 9, to increase the university's financial resources. It's really, we have to look at that carefully. We can understand this goal from the objectives that follow: to establish the university endowment fund, to establish a system of university investment projects, which now maybe in the implementation stage we'll look at that carefully, to develop a community service and continuous education center. We have such a center, but we want to improve such a center, to develop a unit to promote the investment, university qualifications, facilities, and services. The final and the last strategic goal, to develop an effective and supportive organizational structure. And and as a specialized in management, I think we need sort of flexible organizational structure, responsive organizational structure, to be really sensitive for the outside and inside environment. Gentlemen, there are some priorities that the university put, and that will be immediate implementation, and the budgets are ready now to put these priorities into action. There are about 10 priorities. The first one, to identify a written university educational philosophy and monitor its applications among academic practices. Actually, the budget was put for this project, and I think the implementation will be very soon. The second priority, to develop an excellent program for orientation year students. As you know, the Saudi universities, the students, when he comes or she comes, they go through 1 year, we call it orientation, where they are given English language and other courses. Third, to accomplish the structuring of the university's hierarchy, councils, and academic programs, to develop university curricula for all programs to meet quality standards. That's, it's a priority for improving the curricula. To establish a university smart campus and transformation to e-transactions. There are 5. Thank you very much for your attention. Any questions? Yes, sir.
Yeah, notice. So, is there an active discussion relative to the role of research and where?
Yes.
Position, research.
Yeah, Dr. Washington, that's really very important question, which we've been through very extensively. This is a new university, and we tried, or the team tried, to put a realistic vision and goals. A university such as Salman bin Abdulaziz, it's only 3 years old. We said, for the next few years, if we concentrate on 2 things, education and community partnership, that will be good. But there is a point to ponder here, that don't forget that the strategic planning is a continuous process, always under review. Maybe within the coming 2 or 3 years, for sure, we'll look at research seriously.
Okay, excuse me. Actually, I'm the one of the member of the strategic plans. We did like many workshops, and we collect all. We have like a advisory report from the. We have an advisory report from outside, and we get all the opinion about what we have to see our campus within the 10 years from now. Actually, we just start. We're starting the buildings, and we start the facilities, and we are more focusing in the undergraduate now programs. Our priority now to get the accredited. We like in College of Engineering and College of Engineering Science, we're going to expect the visit of the EBIT visit next year, like this year from now, to start the process. We also focusing on the research is an important aspect within the universities, but we more focusing on the applied research. This is what they go for it now. Right now, we're focusing something we get the student participate in terms of research now, and we developing in this way. But we putting all the resources, all the money we have, because we are lacking human. The people, they get people to work with us to to get our strategic goals, what we're looking for now. So yes, we're going for the research, but we mainly focusing on the applied research for something to get the student participated on now.
Yes.
Okay.
Yeah, it's very important, and I think you should not look over that.
Okay. Any more questions? Any more questions? Okay. We expect to have a presentation from the College of Engineering department, but we're going to have a meeting tomorrow morning. We're going to hold together. We're going to talk more about the academic programs and the interactions. So with tomorrow meeting, we're going to more focusing on the engineering discussions like this. So I just bossed all the other presentation. We talk about it by tomorrow. Eventually, we're going to talk about the many engineering aspects tomorrow. So we would like to thank everybody here.
And thank you very much.
Thank you for that. All right. Okay.